Dear students, let's start with the chapter Organic Chemistry, Some Basic Principles and Techniques. In this chapter, mainly we will focus on few points like what is tetravalency. We know it very well that carbon's atomic number is 6. Its configuration is 1s2, 2s2, 2px1, 2py1. So there are 4 electrons in the outermost shell. That is why it is tetravalent. 4 electrons in the outermost shell, in the valence shell. That is why it is tetravalent. It requires 4 more electrons to become stable. That it does by sharing of its electrons. Tetravalency. Now the second property of carbon is catenation. Now what is catenation? Catenation is self-linking property of carbon. Self-linking, what does it mean? That carbon link with carbon and make a long chain of carbon which is quite stable. So this is called as catenation. Third property is multiple bond formation. What does it mean, multiple bond formation? Carbon can get bonded with the carbon itself by a double bond or by a triple bond. Carbon can form multiple bond with oxygen. It can form multiple bond with nitrogen. So this is another property which make carbon versatile in nature. So because of these 3 properties, that is tetravalency, catenation and multiple bond formation, carbon has versatile nature, and because of its versatility, because of its versatile nature, it can form large number of compounds. That is why we need to study the compounds of carbon as a separate branch that is called as organic chemistry. Now we need to understand what are organic compounds. Organic compounds are either hydrocarbons or their derivatives. Are either hydrocarbons or their derivatives. What does it mean, derivative? Hydrocarbons, what are hydrocarbons? Hydrocarbons are the compounds of carbon and hydrogen. Like if I talk about CH4, if I talk about C2H6, if I talk about C2H2, if I talk about C3H8, all these are what? These are the hydrocarbons, that is compounds of carbon and hydrogen. And if we substitute one of or two of the hydrogens or maybe more hydrogens out of these compounds by some other atom, then it becomes the derivative, and that will also be called as the organic compound. Like say for example, we have CH4. Out of this CH4, if I substitute one of the hydrogen, minus H means going out, and in place of this I brought a group that is say OH, then I got a compound that is CH3OH. So CH3OH is not a hydrocarbon but it's an organic compound. Why is it an organic compound? Because it is the derivative of hydrocarbon. That is why it is a organic compound. So that is how we can have the organic compounds, or the branch of chemistry which deals with the methods of preparation, the properties, the uses, etc. of the organic compounds is called as organic chemistry. Now we are starting with some more important points about the hydrocarbons or the organic compounds. What is this? We need to understand that in the hydrocarbons, that is alkanes, alkenes and alkynes, we studied it in class 10 also, that the carbon can undergo either sp3 hybridization or sp2 hybridization or sp hybridization. Please understand, wherever carbon forms a single bond with other carbon or with any other compound, like say for example, if the compound is like this, having this kind of bonding, so we should pay attention, carbon oxygen is a single bond. Similarly, say we have this type of carbon carbon bond, so this is what this here, carbon is undergoing sp3 hybridization. Wherever carbon will be forming a double bond, maybe with carbon or with some other atom, it is undergoing sp2 hybridization. And if carbon is forming a triple bond, maybe with carbon itself or with nitrogen, then we say it as that it is sp hybridized. So single bonded carbon is sp3 hybridized, double bonded carbon is sp2 hybridized, and triple bonded carbon is sp hybridized. So that is how we can have the different type of hybridization. Now we should understand in which case the carbon is most electronegative. Wherever the S character is more, the electronegativity is also high. Now let's see how is it. Say for example, we talk about this. Here it is sp3 hybridization. So S character is 25%. In this case, it is sp2 hybridization. S character is 33%. Here it is sp hybridization. So S character is 50%. So greater is the S character. Greater S character, more is the electronegativity. Greater S character, more electronegative the carbon atom is. More electronegative the carbon atom is. So this is what we need to understand. Now what about here? Here it is lesser electronegative because lesser S character. In this case it is minimum electronegative. The question can be like we have ethane, CH3, this is ethane. We have CH2 double bond CH2, that is ethene, and we have CH triple bond CH, ethine, in which case carbon is most electronegative. The most electronegative carbon will be in this case, most electronegative carbon. Why is it so? Because in this case the type of hybridization is sp hybridization. That is why it is most electronegative carbon. Now moving to the next concept, that whenever carbon is double bonded or triple bonded, there is always a, if there is a double bond, then there is always a 1 sigma and 1 pi bond. But if there is a triple bond, there is always a, in case of triple bond, 1 sigma plus 2 pi bonds. This is how always it is. Now this double bond containing 1 sigma, 1 pi bond. Pi bond is a very weak bond, and whenever the carbon is sp2 hybridized, the structure is a planar structure. Structure is planar structure. In case of sp3 hybridization, it's tetrahedral structure. So this is what we need to understand. Now what type of questions can be asked based on this? Say for example, we have a compound that is CH3CHO. The question is how many sigma and pi bonds are there in this compound. So how will we count the number of sigma and pi bonds? It's going to be, we have to write the structure of this first of all. CH3CHO, CHO. So here we should understand carbon is bonded only with this hydrogen and this side. So only 2 bonds are there. So remaining 2 should be with oxygen. Like this. So this is how we should do it. Now can we count the number of sigma and pi bonds? How many sigma and pi bonds? If we talk about the sigma bonds are 1, 2, 3, 4, 5, 6. 6 sigma bonds. How many pi bonds are there? 1 pi bond. So this is how we can have the sigma and pi bonds. Now what about how many sigma and pi bonds are present in the compound CH3 CH2CN? How many sigma and pi bonds are there in this compound? Again we have to write the structure of it. The structure is like this, CH2 CN, because carbon is only having 1 bond here, so with nitrogen it should be triple bonded. So how many sigma and pi bonds are there? 1 between carbon and nitrogen, 3 1, 2, 3 are here, so 4 and 4 8. Sigma bonds are 8 and pi bonds are 2. So that is how we can have the questions. Question can be like this also. Identify the type of hybridization of the carbon which is highlighted. So this is the highlighted carbon. What is the type of hybridization? Here again we need to write the structure of the compound. Now if we write the structure of the compound, we are finding that carbon is triple bonded. Triple bonded means it should be sp hybridized. This is another type of question which can be asked from this topic. Now what is the type of hybridization of both the carbons in this compound 1 and 2? In this compound, what is the type of hybridization of both the carbon? So what is the type of hybridization? Here we should observe that carbon is double bonded with oxygen, so this is going to be sp2 hybridized, and here carbon is single bonded, so it is sp3 hybridized. So this is the another way of question which can be asked based on this topic. Now moving to the next. Say for example, we are asked to write the different type of formula of a compound. Like say for example, the formula of a compound is C5H10. C5H10 is what? This is the molecular formula. This is the molecular formula because this tells us about the number of atoms of each of the element present in the compound. Now this molecular formula can have a different structure. What should be the structure of this? That is called as the structural formula. So the structural formula of the compound is like 1, 2, 3, 4, 5 carbons are present and hydrogens are 1, 2, 3, 4, 5, 6, 7, 8, 9 and there are 10. 10th carbon is here. Now it is not possible because carbon should be tetravalent. So what we need to do here, this should be 2 hydrogens and here it should be like this, 2 hydrogens. So now the valency of each of the carbon is satisfied, and here you should see we have written the structure of the compound. This is called as the structural formula. Now we can write the same compound in other way also. What it is? That is the condensed formula. How can we write the condensed formula of it? This is CH3 group. Let's write CH3 group. This is CH2. This is again CH2. So CH2 is coming twice. So let's write CH2 like this. CH2 whole twice. Then we have CH double bond CH2. This is what? This is the condensed formula of the compound. Condensed formula. Then we can write the same compound in other way also. What it is? That is with the help of bond line notation. Now what is this bond line notation? Bond line notation where each of the carbon bond is represented with the slanting elongated line, and each of the end or the intersection represents the carbon atom. Like say for example, we write like this. So each of the end is carbon and this carbon-carbon bond is elongated, right? So which compound is this? It is CH3, CH3. Now similarly, we can write the bond line notation for this compound also. What is it going to be? Here how many carbon? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5 carbons. And where is the double bond present? Double bond is present here. So this is what? This is the bond line notation of the compound. So this is how we can have the various kind of formula for the compound. Now all this, whatever we have done till now, are the two-dimensional representation of the compounds. How can we represent a compound in the 3D? 3D in the sense, how can you say that what is the position of the particular atom or a group in the three-dimensional space? Is it towards observer or is it away from the observer? How do we represent that? Like if it is a tetrahedral structure, how can we represent that? So let me tell you, say for example, if it is CH4, here carbon is sp3 hybridized, right? So how do we represent the structure? There are four hydrogens bonded. So 2 hydrogens which are in plane with carbon can be represented like this. Now remaining 2 hydrogens are either one is towards the observer, Other is away from the observer. The away from the observer one is always represented with the dashed wedge, like this. So this is away from observer. And the atom which is towards observer is always represented with the help of solid wedge, like this. So this is how we can have the three-dimensional representation of the compound.